Hi friends, how are you all of you? Welcome back to my physics channel. And we are in the 13th chapter, second last chapter, that is 13th unit, Nuclei. Now let us start with the 4 marks questions for the new syllabus. We are having only 5 questions in the 4 marks. Let us start with the 4 marks. This is the 7th video. Okay na? Short answers, then under short answers, 4 marks. Short answers. Okay, so these are 4 marks questions and very easy questions. 4 marks and తెలుసు కదా, these are helpful in scoring 85 marks. First question చూడండి ఏమన్నాడు, what is nuclear fission? Give an example to illustrate it. What is nuclear fission? Yeah, చూసుకోండి fission. Okay, give an example to illustrate it. See, as I told you in the before concept, nuclear fission అంటే ఏంటి? A heavier nuclei like uranium-235 isotope bombards with a slow moving neutron, that is thermal neutron, and splits up into 2 nearly equal masses like barium, krypton, with 3 electrons released and with huge energy around 200 million electron volts anamata. So that is the perfect definition of nuclear fission. Ade kada adigadu manaki. What is nuclear fission? Give an example. Nuclear fission is a process in which a heavier nuclei like uranium-235 or 238 bombards with a slow moving neutron or thermal neutron, okay, and splits up into 2 equally near masses like barium and krypton, nearly masses anamata, and 3 neutrons are released for every fission. Adothundi kada. So nuclear fission ante a heavier nuclei like uranium 92, 235 or 238, okay, splits up into 2 nearly equal masses like barium and krypton, and with 3 neutrons. With the 3 neutrons for every fission. For every fission reaction and with huge amount of energy. For every fission reaction with a huge amount of energy. With huge amount of energy. ఇది మనకి డెఫినేషన్ అనమాట. ఎగ్జాంపుల్ అడిగాడు. ఎగ్జాంపుల్ అంటే ఏంటి? రియాక్షన్ ఇవ్వాల్సిన ఎగ్జాంపుల్ ఏమడిగాడు వాడికి? యూ కెన్ టేక్ ఆటమ్ బాంబ్ ఎస్ ఎగ్జాంపుల్. బెస్ట్ ఎగ్జాంపుల్ ఎస్ ఆటమ్ బాంబ్. ఓకేనా? వాడు అడిగింది ఏమడిగాడు? గివ్ ఎన్ ఎగ్జాంపుల్ టు ఇలిస్ట్రేట్ ఇట్. ఆటమ్ బాంబ్ ఇస్ ద బెస్ట్ ఎగ్జాంపుల్. యురేనియం మీకు కావాలంటే రాసుకోవచ్చు, ఎందుకంటే 4 మార్క్స్ కాబట్టి. 235 bombards with a slow moving neutron, goes to excited state uranium-236 and splitting up into 2 equally masses barium, krypton 56, 36, 91, 142, 3 neutrons plus 200 million electron volts. This is the equation of the fission reaction. You can balance 235 plus 1, 236, 92, and you can see here 142 plus 90, 91 plus 3, 91 plus 3 anta 94, so 236 balanced. So this is the equation for the nuclear fission. Clear? That's it. And note chesaru kada. Let us go to the next question. 4 marks. Short answers kabatti dani taggatu rayalani, otherwise you won't get score. Example atom bomb you can take. Also you can take plutonium bomb 1945 Nagasaki. Okay na? Hiroshima and Nagasaki. Example plutonium bomb. Second question, what is nuclear fusion andi? Ipudu rendodi. Second thing adugutunnadu, what is nuclear fusion? Okay na? Example, explain with concerned reactions. Explain with reactions. 4 మార్క్స్ కాబట్టి దాని దగ్గర ఎక్స్ప్లెయిన్. ముందు అసలు న్యూక్లియర్ ఫ్యూజన్ అంటే ఏంటి? 2 lighter nuclei combine to form a heavier nuclei like deuteron. At the same time, huge energy is again released. That is called as nuclear fusion. Two lighter nuclei, proton and proton, combine to form a heavier nuclei. At the same time, huge amount of energy is released, and that is called as what? Fusion. And for example, 1H1 plus 1H1, 2 lighter nuclei, that is proton gives rise to 1 deuteron, heavy hydrogen 1H2 plus a positron, antiparticle of an electron, positron plus amount of energy. Check చేసుకోండి. 1 plus 1 2, 1 plus 1 2, 2 plus 0. ఇంకేమడిగాడు మనకి? ఎక్స్ప్లెయిన్ విత్ కన్సర్న్ రియాక్షన్స్ అన్నాడు. యూ కెన్ గో విత్ రియాక్షన్స్. అగైన్ డ్యూటరాన్ రియాక్ట్స్ విత్ ప్రోటాన్. డ్యూటరాన్ ఇది. అగైన్ ప్రోటాన్ gives rise to helium isotope He23 plus Q2. Equation 1, equation 2, 1 plus 1 2, 2 plus 1 3. Again helium isotope combines with again proton. This is helium isotope combines with again proton, gives rise to helium nuclei and He24 plus E plus 1 0 plus Q3. Equation 3 ఒకసారి చెక్ చేసుకోండి. 2 plus 1 3, 2 plus 1 3 plus 1 4 plus 0. So these three are called as very very important అండి. proton cycle, and then these are used by the energy of sun and stars, thermonuclear reactions. ఇదండి ఫ్యూజన్ అంటే. 2 lighter nuclei, proton combine to give a heavier nuclei like deuteron with huge amount of release energy, and you are getting a positron and here antiparticle of electron, antiparticle of electron. That's all, and that is regarding the second 4 marks question, nuclear fusion with concerned reactions. Third one, chairperson John, 1 2 3. Third question, 4 marks. ఓకేనా? రైట్. ఏమంటాడు చూడండి. ఎక్స్ప్లెయిన్ ద ప్రాపర్టీస్ ఆఫ్ న్యూక్లియర్ ఫోర్సెస్. Explain the properties of nuclear forces. First one, these are non-central forces. Non-central and for example like gravitation acts along the central line passing through the center of masses. That's gravitation force. Okay na? So this is not gravity, therefore these are non-central forces, won't act along the center to center. Next property, these are the strongest force in the universe. These are the strongest forces in the universe. These are the strongest forces in the universe out of all. That is 10 to the power of 38. Electrostatic 36, gravitation 1. This is nuclear force. This is electrostatic force. This is gravitation force. So least is this one, and this is the highest, nuclear force. Next is electrostatic force. So these are the strongest forces in universe. Okay na? Tarvata, the forces are same between neutron, proton, and proton. అదవుతుందా? న్యూట్రాన్కి ప్రోటాన్కి ఇప్పుడు సేమ్ ఫోర్స్. ఓకేనా? దట్ ఈస్ అనదర్ వన్ యూ కెన్ టేక్. అదవుతుందా? నెక్స్ట్, దీస్ ఆర్ స్పిన్ డిపెండెంట్. 4 మార్క్స్ కాబట్టి కనీసం 4 రాయండి. దీస్ ఆర్ spin dependent. The forces are same between neutron, proton, which keeps the nucleus stable inside. Tarvata, these are spin dependent. Inko point would raskondi. Another important point, these are short range forces. These are short range forces. These are short range forces, that is around 10 to the power of minus 15. That is nothing but 1 Fermi. Short range forces, that is around 1 Fermi, 10 to the power minus 15. Okay, na? Right, Andy. So these are some important properties regarding nuclear. These are the strongest force in the universe, 10 to the power 38. Next is electrostatic, least is gravitational. Non-central, they don't act along the center of masses. The forces are same between neutron, proton, and proton. They are spin dependent. Short range forces around 10 to the power minus 15, that is Fermis, 1 Fermi. Okay, na? Cherpastanandi. Next question andi, 4 marks. Okay, right. So 4 marks kabatti dani taggatu rayalandi for the scorings. Next question, second last one. Explain the terms. Fourth one, mass defect. Explain the term delta M, that is mass defect. Tarvata binding energy with mathematical expressions. With mathematical, okay, na, expressions. Okay, na, start chedam mari. Right andi. Explain the terms mass defect, binding energy and mathematical. So mass defect ante entante, see here, it is the difference between the mass of the constituents present inside the nucleus to that of the stable nucleus. Nucleus lopala nucleons untayi kada, protons, neutrons, that mass and a stable mass, the difference is called as, according to Einstein, mass defect. Difference between the mass of the constituents present inside the nucleus. It is the difference between the nucleons, that is protons and neutrons, present inside the nucleus and stable nucleus. And the stable nucleus. So, mass defect ante delta M and you chubistam mathematical ga. So, it is the difference between the mass of the, difference between the nucleons, mass, difference between the nucleon mass, nucleon mass, that is protons and neutrons present inside the nucleus, to that of the stable nucleus mass. Mathematically ఎలా రాస్తాం? Mathematically delta M is written as in this fashion. చూడండి, proton plus neutron A minus Z, this is the nucleon's mass minus mass of the stable nucleus, and this is equal to delta M. So this is the mathematical expression for mass defect and protons plus neutrons. This is the mass of the nucleons, and of course this is greater because of the energy is converted into mass, and mass is converted into ikkada emavuthundi koncham mass gaayamaipotundi. It is converted into binding energy to keep hold of the intact anamata, nucleons ni tight ga unchadam kosam, that whatever mass is changed into energy, binding energy. So this value is greater than the stable mass, and which is equal to delta M. This is the mathematical formula. Now coming to binding energy. Binding energy is the minimum energy required to break the nucleus. And whatever energy is required to form the nucleus, same energy is required to break the nucleus. So binding energy and other it is the minimum energy. It is the minimum energy used to break the nucleus. into nucleons, that is protons and neutrons. That minimum energy used to break the nucleus into nucleons, proton, neutrons is called as binding energy. Okay na? So note cheskundadi. Please, it is the minimum energy andi. Okay na? Required to break a nucleus into its nucleons. Mathematical formula అడిగాడు. దానికి ఏంటంటే చూడండి, binding energy is given by delta M into 931.5 million electron volts is another mathematical formula. By using Einstein's equation, E is equal to mc square or delta mc square. Delta M mass defect andi in AMUs. Okay na? And one AMU మీకు తెలుసు కదా 1.67 10 power minus 27 kgs. And always it is measured in electron volts or millielectron volts, not in joules, because it is a modern physics. So binding energy formula ఏంటి, mass defect into 931.5 millielectron volts. This is the mathematical formula. And ఎలా వచ్చింది తెలుసు కదా, from E is equal to mc square. So from this formula we got these values. C value 3 into 10 power 8 meters per second, please. So that's all about the fourth question andi, mathematical. Last one, distinguish between nuclear fission and fusion. Last one, last 4 marks. Distinguish అంటే difference something ఏం లేదండి, differences రాద్దాం. ఒక మధ్యలో గీత కొట్టేసి ఎక్స్ప్లెయిన్ చేస్తే సరిపోతుంది కదా. ఓకేనా? So you have to differentiate 4 marks కాబట్టి. Distinguish between nuclear fission and fusion. చూడండి, I'll drop a line in the middle. మధ్యలో గీత గీద్దాం. గీత గీసి ఇక్కడేమో ఇది న్యూక్లియర్ ఫ్యూజన్, ఇది న్యూక్లియర్ ఫిషన్. ఓకేనా? So differences one by one ఇద్దాం. First one you can make it like this. First one, what is nuclear fusion? Fusion means two lighter nuclei combine to give a heavier nuclei. Two lighter nuclei combine to give a heavier nuclei. ఇక్కడ ఏంటి, ఏ heavier nuclei fission లో a heavier nuclei splits into two nearly equal masses. After bombarding with a slow moving neutron, two lighter nuclei combine to give a heavier nuclei like deuteron. Heavier nuclei splits into two nearly equal masses after bombarding with a slow moving neutron or thermal neutron. This is nuclear fusion. Fusion example you can take it as 1H1 plus 1H1 gives rise to 1H2 deuteron plus positron plus energy. You can see 2. You can give the example for here. Heavier nuclei 92, 235 plus slow moving neutron goes to excited state 236, and it is splitting into barium plus krypton 56, 36, 91, 142, 3 neutrons plus energy 200 roughly. Third one, in fusion you can take example for hydrogen bomb. Fission you can take as atom bomb example or plutonium bomb. These are done in thermo, that the energy of sun and stars. Energy of sun and stars. Okay? Energy of sun and stars. Nuclear fusion. Okay na? దీన్ని you can take it as fission, nuclear reactors, syllabus లో లేదు of course, ఏ తీసాడు. nuclear reactor, you have so many nuclear reactors, ఓకేనా. అండ్ ఇదేంటి, these can be used as peaceful as well as disaster purpose. మీకు డౌట్ రావచ్చు, డిజాస్టర్ ఏంటి, పీస్ఫుల్ మీన్ టు జనరేట్ ఎలక్ట్రిసిటీ, by using controlled chain reaction, disaster means uncontrolled chain reaction, like atom bomb example. Okay, 3 neutrons giving rise to 9, 81, geometric progression. Okay na? And energy of sun and stars, you can get nuclear fusion, hydrogen bomb. So these are the major different. Inkoti maro chaala important point last di nuclear fusion lo 24 MeV energy, ikkademo 200 MeV per fission. Tarvata, this is more dangerous than this thing, atom bomb kana hydrogen bomb is more dangerous because the average binding energy is 6 to 7 times. That is mass number by energy by mass number, 24 by 4, 6 MeV. ikkademo only 0.85 MeV vastundi average binding energy. That is uranium is 235 mass number. If you divide 200 by 235, you will get 0.85. So this is less dangerous fission, this is more dangerous, 6 to 7 times. So these are the major differences between nuclear fusion and fission reaction. Ardhavutunda? So these are 5 important 4 marks question andi, scoring for 85 in second year physics. And that's all for the short answers andi. Again I'll be meeting another 4 questions are there in long answers, 8 marks in the next video please.